This question's about maximum speed and kinetic energy within simple harmonic motion. And you can equate the displacement with the velocity within simple harmonic motion, and you can do the calculations. And it involves a little bit of calculus, and it involves finding differentials of trig functions, which you may be able to do, and you may find that quite a satisfying thing to try. But you are given quite a lot of this information within the data and formula booklet, and the expectation is that you will use this to help you quickly get to answers rather than having to do everything from first principles. So we've got the displacement, x is a cos omega t, so we're given that, and we're told that the speed of an object moving with SHM is v is plus or minus omega, and then we've got this relationship between the amplitude and then the position x. So that's the speed at any given time, speed at any given displacement, and the displacement is a function of time. However, we've got a shortcut really where we can get to V max, and V max is omega A. So we've got that value to get us to the maximum value of kinetic energy. The kinetic energy is being exchanged with the potential energy. It's SHM. We're not told what's going on. We're just told it's oscillating, but there'll be a potential energy there. So there's an exchange between kinetic and potential energy, and we're only interested in the maximum kinetic energy. So the maximum kinetic energy we'll get from the maximum speed. Maximum kinetic energy will just be the kinetic energy at the maximum speed. So we need to find omega, we need to find A, and then we need to put it into a half mv squared. So let's have a look at the information we're given. We're given mass, we're given amplitude, and we're given frequency. So we'll be able to get from frequency to omega. So omega, the angular speed, so it's the number of radian it cycles through per second. That is equal to how many full cycles it goes through multiplied by how many radian there are in a full cycle. So there are 2 pi radian in a full cycle, and it's going through, in this case, 0.8 full cycles a second. So we can get omega because it's 2 pi multiplied by 0.8. So that's 1.6 pi, but I will do the calculation on my calculator. So 2 times pi times 0.8 gives me omega equal to 5.0265 and some other numbers, and that's radian per second. So that's my omega value. And now I'm going to use the equation to find the velocity. So V max is what I'm interested in, is just this omega value that I've just worked out multiplied by the amplitude. So it's 5.0265, which I've still got on my calculator, and I need to multiply it by amplitude. Don't get caught out, it's in millimeters, 55 times 10 to the negative 3. So multiply that by 55 times 10 to the negative 3. Gets me that the maximum velocity is 0.27646 meters per second. Not finished yet. Now I've got the maximum. I want the KE maximum. So the KE maximum is a half mv squared, where v is V max. And then the m I've given in the question is 0.15 kilograms, and then multiplied by 0.2764, etc. all squared. Don't forget to square it. I've still got that velocity value in my calculator. So square that, multiply by a half, and multiply by 0.15. And I get that the maximum kinetic energy is 5.7 times 10 to the negative 3 joules.